Okay, so we're still on 4.4, and this video here, then we'll talk about how do we find a spanning set given a vector space. Okay, so this is the type of problem we're dealing with, and this is still from the book. This is 4.421 now. And the problem is this: let S be the subspace of M3R, so 3 by 3 matrices with real entries inside, consisting of all 3 by 3 matrices such that the elements in each row and each column sum to 0. Alrighty, so how do we do this? Well, S is a subspace of 3 by 3 real matrices, and S has this unique property that we need to satisfy. And so we can first start off by writing out just a few examples, right? So the goal of this problem is to find a spanning set. Of S. So we can start off by just writing some examples of S. All right, so how do we do this? Well, okay, we can say 1, and then if we have 1, then this has to be like -2, right? And then if this is, let's say, 2, and this is 4, then this has to be -6, and then we're kind of forced into what this last row has to be, right? Because the columns have to sum up to 0. So you got 1 plus 2, so this needs to be -3. 1 plus 4, this needs to be -5, and then 2 minus 6, so this needs to be +8, right? Because the rows and the columns have to add up to be 0. All right, so this is an example. What else is an example? Well, you can just have, let's say, 1, 0, -1, and then 0, 1, -1, and then this becomes -1, -1, 2, right? And so forth, etc., etc., etc. But notice what we're doing here, right? Notice that in both of these examples, I can choose whatever this entry is, okay? I can choose whatever the next entry is, but this is kind of like playing Sudoku, right? I'm forced into this third entry being -2 if I choose 1 and 1, because the rows have to add up to 0. Likewise, if I go down the column, I can choose whatever that wants to be. But then again, I'm stuck with then the last entry in the column is forced to be a certain value, right? And because of this, we can find a spanning set. And how do we find a spanning set? Well, we have to essentially start by describing the spanning set as a bunch of variables. So how can I turn this matrix here and this matrix here into variables? Well, let's see. So let's try to do this. Well, remember, so this first entry, I can choose to be whatever I want it to be, right? And so in terms of variables, let's just call this first entry then A. All right, so I can pick that first entry to be A. Then my second entry can be anything. So, all right, so here, let's call that B, right? But what does this entry here in the 1, 3 slot have to be? Well, my rows have to sum up to 0, and so it has to be -A minus B, right? Because then A plus B minus A minus B is 0. So this entry has to be -A minus B. All right. All right, let's continue then. Okay, what else can I choose? Well, this entry in the 2, 1 slot, it can be anything, right? And so it can be C, all right? What else? Well, this entry here can be D, right? There's no restrictions there. And then, okay, but then this last entry in the 2, 3 slot has to be -C minus D, right? And then what? Well, and then we see that, oh, here, this last entry in the 3, 1 column, right? In the first column, third entry, or it's called the 3, 1 entry of the matrix, this has to be -A minus C because the columns have to sum up to 0. Likewise, this column has to be -B minus D. And then we run into some fun stuff. What does this column have to be? Well, you have negative A minus B minus C minus D plus something is equal to 0, well, this entry down here is actually A plus B plus C plus D. Okay? And so now we can find our spanning set. And how do we find our spanning set? Well, we do it like this, right? So we can take our matrix and we can break it up. We can say this is equal to, this matrix here is equal to what? It's equal to A times 1, 0, negative 1, right? Because here's A is times multiplied by negative 1 here. A is multiplied by 1 here. Okay? Well, notice A is multiplied by negative 1 here, and A is multiplied by positive 1 here. And then negative 1, 0, 1 plus B times 0, 1, negative 1, 0, 0, 0, 0, negative 1, 1. Okay, because I look at where B is. B is here, 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 and here. And notice here's a negative sign. So here's a negative sign. Here's a negative sign. Here's a negative sign, etc. Right? Plus C times 0, 0, 0, 1, 0, negative 1, negative 1, 0, 1. Okay? And then plus D times 0, 0, 0, 0, 1, negative 1, 0, negative 1, 1. And now we have our spanning set. Well, what is our spanning set? Our spanning set then are just going to be these 4 matrices right here. Notice we don't want the A, B's, and C's inside because I guess it doesn't matter because they can be anything. But in general, you don't have to leave the variables out. The variables are just there to help you find this spanning set. And so these 4 matrices are going to be our spanning set. Okay, so this is our spanning set. And just a little later, I think in 4, 6, right, 2 sections from now, we're going to notice that this is actually a basis. We actually just found a basis, and a basis for a vector space is always going to be a spanning set. So we'll leave that for 4, 6, but notice that this is how you find a spanning set, and I'm technically teaching you guys how to find a basis as well in the same video. So if you are stuck in section 4, 6, you can actually come back and watch this video because this actually teaches you how to find a basis. But notice this question then is, how do we find the spanning set of the subspace of M3R that consists of all matrices where the rows and columns both sum to 0, and this is how we do it, right? We just start off by creating some examples, and then we realize, hey, we have to do it generally with all these variable unknowns with A's, B's, C's, D's, etc. And then we just plug them in until entries get forced into being certain entries. And then from that, we extract out a linear combination where we have A times a matrix, B times a matrix, etc. And finally, we take these matrices, these 4 separate matrices, and that forms the spanning set for the subspace. And yep, that's how you do it.